Okay, hello again, back with an example here if you decided that you wanted to see another worked out example of how to do a defective matrix with repeated eigenvalue. So we have this problem right here. We do have an initial value problem, and so that is something that was not covered in the last video, so we'll get to kind of see what that looks like. And like before, I just already worked out the characteristic equation, so we don't have to do that piece together. So here, obviously, we see you get a repeated eigenvalue of 1. So we're going to go ahead and evaluate A minus the lambda identity matrix, which will give us 1, 1, -1, -1. So I'm going to go ahead and augment that with 0, 0. So like you can see, row 2 is going to be pretty useless to us. So we're going to go ahead and just take row 1, which gives us that x1 plus x2 is equal to 0, meaning any x sub 1 we pick will be the negative x sub 2. So what I chose for this was just to do 1, -1. And so that's my eigenvector here is 1, -1. And now you can see, and I mean, you can test this out that, the reason we know this is defective is like any scalar multiple I use, I'm going to get the exact same eigenvector. There's no other way for me to get a different eigenvector here if all I'm doing between x1 and x2 is changing the sign of it. Okay, so this is defective. So we're going to go ahead and we're going to launch back into what we used for finding y sub 2, which is the fact that I'm going to take A minus the lambda identity matrix to find x2. But remember, we're going to augment that instead with what we got here for x sub 1. So what that's going to look like, the same A minus lambda identity. So we're going to get 1, 1, -1, -1. But now that gets augmented with what we found for our x sub 1, which was 1, -1. Okay, row 2, still pretty unhelpful, but this now at least tells me that if I take x1 plus x2, it's going to be equal to 1. And so I can get a different eigenvector from that. And so in fact, what I did was I just chose to make x sub 2 equal to 0. So we'll just call x sub 1, 1, and that means x sub 2 would be equal to 0. And then I see that I get a linearly independent eigenvector. Okay. So there's my x1 and x2, and we're going to use the form for the general solution here, meaning that we're going to say that y of t is equal to c sub 1 e to the lambda t. Lambda was that repeated eigenvector of 1, so it's just going to be e to the t times what we got for our first eigenvector, plus c sub 2 times this whole quantity here. So t e to the lambda t times 1, -1, our x sub 1 eigenvector. And then we are going to say plus e to the lambda t times our second eigenvector. All right, so, and this is why, in that last video, I just encourage that you use the matrix form of this, because remember, we're going to go ahead and solve the initial value problem for this one. And so in matrix form here, this looks like e to the t plus t e to the t plus e to the t if I just go down the line. And then we get a negative e to the t. Rosie just came down to say hello. I don't know if you hear her jingling in the background, but she is here. And then we get a negative t to the t, and then this gives us 0. So we have this, we have C1, C2. Okay, so I'm going to go ahead and I'm going to simplify this just a little bit. And what I'm going to do is write these as individual elements in the matrix here. So by that, I mean, I'm going to go ahead and, I'm going to actually separate out, when I talk about doing the elements, I'm going to separate these back just a little bit. So I'm going to do the e to the t for element 1. Whoops. Let me undo that. Go back to black here. E to the t for element 1 right here. And then this t e to the t plus e to the t will be times c sub 2. So we'll go ahead and just leave that. And then same thing for row 2 here. I'm going to just separate these back out. So I get a negative e to the t for my first element. And I get a negative, sorry about that, a negative t e to the t for that element right there. This will make it a little easier. When we go to look at our fundamental matrix, we get psi of t is equal to exactly that. Now, a lot of times too, what people like to do is factor out that common factor of e to the t. You could totally do that if you want to. All right. But then let's keep in mind too, our y of 0 is equal to 3, negative 1. So we have y of 0 is equal to 3, negative 1. So I'm going to go ahead and evaluate psi of 0, because remember that if we want to use the fact that if I evaluate it at 0, I can augment it with y of 0 and then maybe do some row operations here, because y of 0 is equal to psi of 0 times that C matrix. Okay, so instead of finding an inverse, which you could easily since this is a 2 by 2, I'm just going to do row operations. So psi of 0 will look like 1, 0 plus 1. So go ahead and just simplify that. Negative 1 and then 0. And then I'm going to augment that with 3, negative 1. And we're going to do some row operations here. So what I'm going to do is actually just add row 1 plus row 2, because if I do row 1 plus row 2 and put it in this second position here, that actually will eliminate my x, and that'll give me what y equals. I don't know why this is glitching out on me right now. And then 3 plus a negative 1 here would give me that x sub 2 equals 2. I think I said y, but x sub c sub 2. How about that? Man, we got a lot of variables. C sub 2 is equal to 2. Okay, and then I'll keep this as 1, 1, 3. So if I do that, then I can go ahead and do row 1 minus row 2 to eliminate that c sub 2 term. And I'll do that to replace this first row right here. I'll take row 1 minus row 2. And I will get 1, 0, and then I get a 1 right here. So a couple of basic row operations for this one. Hopefully, if you decided to solve using an inverse matrix, that you also got that C sub 1 here would equal 1 and C sub 2 would equal 2. Okay, so that's what we get solving for those. Now, keeping in mind that we are going to take that and we are going to plug those right back in up here. So I'm going to go back to what I wrote out for my general solution, and we are going to plug in 1 for C sub 1 and 2 for C sub 2. So y will look like this. And then doing my matrix multiplication here, I will get 1 times e to the t, and then I have to distribute the 2. So I will get 2t e to the t plus 2e to the t. And then here it looks like negative e to the t minus 2t e to the t. And again, you could combine your like terms here with those e to the t's and make it 3e to the t. Totally fine either way. But that would be our particular solution for y.